Now, using reflection. Reflection is used in many varied different applications, and one of them that is an interesting use of reflection is in a periscope. If we position two plane mirrors at 45 degrees to each other at either end of a tube, we can make a periscope. So this means that we can see objects at different heights. So if we were to look in at the bottom, if we had an object at the top, the rays of light would come from the object, be reflected by the mirror. They would then meet the second mirror and be reflected again to our eyes. Periscopes are often used in submarines so that they can see objects on the surface of the water when they're below the water. So this is your eye, and remember that the light ray always comes from the object that you're looking at. So this is the object and this is your eye, and the light rays come from the object via reflection to your eyes, and this is how we see them. Now that's the applications of reflection. One of the important questions that can often come up in the exam is to actually draw the location of the image that is formed whenever light is reflected in a plane mirror. In this case, we have a source of light, which is just a light bulb in this case, but it could be any object. And then we have our eye line here, and we're asked to draw a location of the image that is formed in the reflection. We talked earlier about the image is the same size as the object, and it's also the same distance from the mirror as the object. And it's virtual. Virtual means it is an image that we cannot capture on a screen. To be able to draw the location of the image, there are two techniques to this. I will show you the first one and then explain the second one. The first one, you pick a point on the object and draw a ray of light from the object to the mirror. Now, we know that that ray of light is reflected by the mirror, but we don't know exactly how much it's reflected. So, in this case, we must draw a normal at the point where the ray joins the mirror. So we set our protractor carefully on, and we line up the 90-degree line with the mirror, and we can see the 0 line, and we can put a dot at the end of it. Then with our ruler we can draw a normal lined up with that position. So remembering that that's a normal. Then put our protractor back onto the mirror, line up the 0 line carefully with the surface of the mirror, and we measure the angle of incidence. Now let's remember, the angle of incidence is that between the incident ray and the normal. So it's this angle here we're interested in. And when we count this round, this is at 15 degrees. So we'll write that in. 15 degrees. I tend to write in the value so that then I don't forget what it was. So this was at 15 degrees. And when we line it up carefully again, if we measure around 15 degrees and put a dot and bring the ruler back in, we can draw the reflected ray. Then we take another ray of light from that same point at a different angle to meet the mirror. And we follow the same process again. Let's make our normal. And repeat that process. So, having done that, if find this angle was 25. Having done that and drawn the second reflected ray at 25 degrees, we then use a ruler and we set the ruler on the first reflected ray, and we continue the reflected ray behind the mirror, but because it's a virtual image, as we discussed earlier, we use a dotted line and continue that quite far back. We then follow the same process for the second ray. And where the two rays meet is the corresponding point on the image. So we'll mark that as I. You could then draw your bulb or so on, but it's easier with an X actually. So this is the object and this is the image. Now we said earlier that the image is the same size as the object. Also that the image is the same distance from the mirror as the object. If we measure the distance from the front of the object to the face of the mirror, we see there that it's approximately 8 centimetres, 7.9 centimetres to be exact. And then if we measure the second one, it's also at 7.9 centimetres. It's also at the same height. When you look at the mirror, look in a mirror yourself when you're getting ready for school in the morning and so on, your image is at the same height as you are in the mirror. Now, this brings me then to the second method of drawing the image formation. To check that my diagram is correct, I measured the distance from the object to the mirror and then from the mirror to the image. What you could do in the exam, a quicker way to answer the question, is to set your ruler on, making sure that it's perpendicular to the mirror surface. Measure the distance, then measure the same distance from the back and put a dot and draw these backwards as a dotted line with a ray, a dotted line with a ray, and then draw in your incident rays back to front. This technique, both of them, are something that you should practice on several occasions before the exam so that you are able to draw these accurately and also able to draw them efficiently so that it doesn't take you too long in the exam and use up a lot of your time. So let's remind ourselves about the properties then and reflection. In a plane mirror, the image is the same size as the object. If you look in the mirror, you're the same size in the mirror as you are in actual life. The image is the same distance from the mirror as the object, and we can do experiments to prove that. The image is laterally inverted. We know this because of the use in terms of the ambulance and the emergency services. And the image is virtual. And the statement that the image is virtual means